So the last section is section 10.7. And we are looking at solving linear, nonlinear systems. So when we solved equations with two equations with two variables or three equations with three variables, nothing was ever squared. Everything was all the variables were to the first power. So now we're going to add in the layer of squared variables or quadratics. So we'll do two types of systems of equations, and then one system of inequalities. So the first system of equations will be a linear, this is a brand new pen, so I think it's still trying to figure itself out, linear quadratic system. So then you'll have one equation will be quadratic. So let's do 3y plus x squared minus 4x minus 17 equals 0, and 3y minus 10x plus 38 equals 0. My recommendation when you have a linear quadratic system is to work to solve by using substitution rather than elimination. So we're going to use substitution on these. Look at your linear system, or rather your linear equation, and solve for one of the variables. Now I'm looking at this, I want to work smarter, not harder. So when you look at the quadratic, notice that they both have a 3y. So I think I'm going to isolate this 3y and use that as my substitution. So in this linear equation, 3y equals 10x plus 38. So when I've solved for 3y, I can substitute that in for this 3y up here. So 10x plus 38 plus x squared minus 4x minus 17 equals 0. So now I'm in terms of at least one variable. Even though I've got a quadratic and linear term, at least it's all in terms of one variable. When the quadratic and the linear show up together in the same equation, first I would shoot for factoring. So let's rearrange this so that it is in descending order. So that's going to be plus 6x, combining like terms, and then a 38 and a negative 17. So that will give me a positive, oh gosh, this should be a negative 38. Mrs. Carty. See, I just can't live without you guys in my life. I make mistakes. That will be a negative 55 equals 0. Okay, so then we can factor this. So x minus 5 and x plus 11. So we've got x equals 5 or x equals negative 11. Now we can go back to our linear and solve for y. Actually, I'm going to go back to this version of the linear because y is almost all the way isolated. So I've got 3y equals 10 times 5 minus 38. So that's 50 minus 38, which is 12. 3y equals 12, so y equals 4. So in this case, when x is 5, y is 4. And then over here, let's do the same thing, but we're going to use negative 11. So 10 times negative 11 minus 38 equals, this is going to be a big number. I think it's 149, and I only know that because I just did this problem a little bit earlier. So y equals negative 149 divided by 3, which 3 does not go in evenly, so I'm just going to leave it. Or you can turn it into a mixed number, that's fine. But when x is negative 11, y is negative 149 over 3. So that is a linear quadratic and quadratic system. So now let's do a quadratic system. Here we go. So quadratic system. All right, right, so here's an example. Let's do x squared plus y squared equals 8, and x squared plus 3y equals 10. All right, so it looks like we have a circle and maybe an ellipse. I don't know, we'll see. Doesn't matter really. We're not asked to identify them at this point. So I've got a quadratic. The way I would solve a quadratic is using elimination. Alrighty. And so take a look. Our x squared terms look like they're the candidates that will be eliminated. So I will rewrite the top one, and then the lower equation I will multiply through by a -1. And so we've got y squared minus 3y equals -2. Again, we've got the quadratic and linear term. So set it equal to 0 and factor equals 0. So y minus 2 and y minus 1 equals 0. So y equals 2 or y equals 1. So let's plug them in. When y equals 2, let's see. I think I will use this one. I don't know why. X squared plus 3 times 2 equals 10, 6. So that'll be x squared equals 4. So x equals 2 or x equals -2. So 2, 2 or -2, 2. So those are two options for y equals 2. And then we'll do the same thing for y equals 1. So x squared plus 3 times 1 equals 10. X squared equals 7. So x equals plus or minus the square root of 7. So our coordinates would be positive square root 7, 2, or negative square root 7, 2. And that would be a quadratic system. All right. Last one is going to be an inequality, system of inequalities. So we get to do some shading on this one. All right, so let's do solve the system by graphing. Oh, look at that, it's 3:30. Okay, x squared plus y squared less than or equal to 49, and x squared minus 4y squared greater than 16. So this is where our knowledge of conic sections is super helpful. I know that this is going to be a circle, right? We've got x squared plus y squared equals r squared, or less than or equal to r squared. So the center of our circle is at 0, 0. So there's the center of the circle. The radius is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So your circle looks something like that. This guy looks like it's probably going to be a hyperbola because of the subtraction sign, but it's not, it doesn't have the 1. So let's go ahead and change it so that it is in a standard form that we are familiar with. I'm going to change it to an equals just for the moment. We'll change it back. So I've got x squared over 16 minus y squared over 4 equals 1. So yes, definitely a hyperbola. The center is at 0, 0. Your a equals 4, your b equals 2. And I know that this is going to be a horizontal hyperbola because x squared is positive. So 4, 1, 2, 3, 4. There's my vertex. 1, 2, 3, 4. There's the other vertex. B is going to be at 2, 1, 2, 1, 2. So we can draw that box in. And then we can draw in the asymptotes that reach from corner to corner on the box. The rectangle, I should say. And then we start and we graph from the asymptote to the vertex. Asymptotes to the vertex, let's see. Okay. Now this guy's not equal to, so I should probably do a dotted hyperbola. There. This is the beauty of expo markers. You guys have to erase. Okay, so there's my dotted hyperbola, but my solid circle. And then we're going to have to do some shading. So let's go ahead and test our point 0, 0. If we plug it into the circle equation, 0 plus 0 less than or equal to 49. Yep, that's true. So everything inside of the circle where 0, 0 is located is shaded. And then we'll test with the hyperbola, 0, 0 again. So 0 minus 0 greater than 16. Is 0 greater than 16? No, that's not true. So here's where 0, 0 is located. We're not going to shade that part. We're going to shade this part of the hyperbola. But really what we're concerned about is where do these shadings overlap? And they overlap in these funny little shapes here between the circle and the hyperbola. And so that would be your solution region for the system of inequalities. So there you go.